Okay, in this section, we're going to discuss something called the imaginary number. And really, there is one imaginary value. However, it makes every other value that's a part of imaginary as well. So it could be considered the imaginary numbers, but specifically, we're going to talk about an imaginary value. So let's go ahead and say that I wanted us to solve an equation. Let's say I wanted to solve an equation where we had x squared plus 1 equal to 0. Now, if I wanted to solve this, I recognize I would subtract 1 on both sides, and that would cancel out here. We're left with x squared equals to a value of negative 1. And now if I want to solve, I have to perform the operation opposite of squaring, which is going to be to take the square root of both sides. And now when I take the square root of my left side, I get a value of x, but this is going to give me plus or minus square root of negative 1. But then you might say, how can we take the square root of a negative 1? There's no value multiplied at times itself that would ever give you a negative, and you would be correct. You would be correct, and this is the basis of our imaginary number system. So let's go ahead and define the square root of negative 1 to be equal to a value of I. And this, by definition, is the imaginary number. There we go. The imaginary number. I'm telling you, spell check has ruined my ability to spell. So this right here is the imaginary number. So every time we talk about an imaginary number, it could be a convolution of I plus something, I minus something. We'll get into that a little bit later. But for right now, we'll define this as imaginary numbers. So there are 4 different ways that I see this used most often. So let's go ahead and talk about the 4 different ways it's used most often. And first of all, we're going to define I as square root of negative 1. Therefore, I squared will be equal to square root of negative 1 quantity squared, and that would equal just to a value of negative 1. I cubed would be equal to the square root of negative 1 quantity squared, still times I, because this is I squared. So let me go ahead and write that out. So we can say that I cubed is I squared times I, but we know I squared is equal to negative 1, so we're going to have negative 1 times I, which is negative I. And then I to the 4th is equal to I squared times I squared, which gives me negative 1 times negative 1, which is a value of positive 1. So as a summary, if you are able to evaluate these and remember this table rapidly or derive it rapidly, you will make your life with imaginary numbers very simple, because every other imaginary value is based off of one of these values of I squared, I cubed, and I to the 4th. I will tell you that these two are probably used most often. You're going to see them used very frequently. For example, let's say I asked you to evaluate I to the 25th. And you say, oh my goodness, that sounds so horrible. How am I going to evaluate I to the 25th? And it's really not so bad, because I like to think to myself, how can I break I to the 25th down into a factor of I to the 4th? Because I to the 4th works out very nicely because it's equal to a value of 1. So let's go ahead and think. Does 25 divide evenly by 4? No, it doesn't. Let us reduce by a value of 1. Okay, 24, it definitely does. So we can write this as I to the 24th, times the value of I, because I to the 1st times I to the 24th gives you I to the 25th. When you have the same bases, you can multiply their exponents. But we can rewrite I to the 24th as I to the 4th power raised to the 6th power, still times the value of I. But we know I to the 4th power is equal to a value of 1, so we can say this is going to be 1 to the 6th power, still times the value of I. And this gives me just I, because 1 to the 6th is just 1. So if you can break down any higher multiple into I to the 4th times some other value of I, you are sitting in a very good circumstance. So let's say I asked you to evaluate another problem. Let's say I asked you to evaluate I to the 31st. Evaluate I to the 31st. So in this circumstance, you're going to say, does 31 divide evenly by 4? No, it doesn't. Does 30 divide evenly by 4? You have to think for a second, but no, I don't think so. And even if you don't get it correct, eventually you'll break it down into one that does. So 29 doesn't because that's odd, but I think 28 definitely does. So I'm going to break this down into I to the 28th times I to some value. 28 plus some value gives you 31. So that's going to have to be a value of 3. So we're going to have I to the 28th times I cubed, because 28 plus 3 gives you value of 31. I can rewrite I to the 28th as I to the 4th power raised to the 7th, still times I cubed. But I to the 4th we know is equal to a value of 1 to the 7th, still times I cubed. But I cubed we see is equal to a value of negative I. So this just simplifies into negative I. So knowing these four relationships here will make your work with imaginary numbers very easy. So we're going to talk about something called the complex number, or complex numbers. So a complex number. Complex number is not as complex as they make it sound to be. A complex number consists of both a real part and an imaginary value. So I guess we shouldn't say real part. I guess I should say a real value and an imaginary value. So we'll say a real value and an imaginary value. A complex number usually falls in the form of a plus b times I, where a is a real number, and b is a real number, but b cannot equal to 0. So people always say, why can b not equal to 0? So let us suppose b equals to 0. We're going to have then a plus 0 times I, and 0 times I, regardless if it's imaginary or real, is going to give you a value of 0, so that just equals to a value of a. And this is just the real part. And a complex number must have both a real, and an imaginary part. So that's the reason why they have to say that it cannot be equal to 0. However, by breaking this down, this portion right here is the real number. And this portion right here, because it contains the I, is the imaginary number. So that's considered a complex value. Let us go ahead and try to evaluate some problems. Let us say we look at an example and try to evaluate the square root of negative 16. So what this really means is what times itself twice gives you negative 16, and clearly there's no value multiplied by itself twice that gives you negative 16. So what I like to do is I like to break this up into the square root of negative 1 times the square root of 16, and we can use a property that allows us to do so. But we know the square root of negative 1 is equal to a value of I, and the square root of 16 is equal to a value of 4. So we would write this solution as positive 4i, because this is an imaginary value, so your solution must have that imaginary I in it. Let us look at another example. Let us say we ask to evaluate or simplify. Let us try the square root of negative 12. Okay, so square root of negative 12 is a little bit more complex, but I'm going to break this down into the square root of negative 1 times the square root of 12. This I'm not going to simplify yet because I want to break that square root of 12 into a perfect square, so we're going to have square root of 4 times square root of 3. So we know that square root of negative 1 is equal to a value of I, and the square root of 4 is equal to a value of 2. So we could rewrite this, or we could write this solution as 2i root 3. There are some people that like to write this as 2 square root of 3 times I, but I don't like that because a lot of times this square root line tends to fall over that I, and this would be incorrect. This would be incorrect. So I often like to write the I as a coefficient in front of the number. So when you simplify these, you can make the simplification process very simple if you just factor out the square root of -1.